I'm not the best programmer in the world, but I am going to. I like working on it. So I also got these linear actuators for the torso when I get there. And we're going to try and get this thing working. So I will show off the progress that I have right now by powering it up. So it cycles between 3 points, and its travel time is set to 100 milliseconds per point, or to get from one point to another. So I will change that to 500 so that it I can stop holding on to it. But yeah, I guess I'll have that running at the same time that I'm doing my my programming. So I put it all down here into this little function outside of the main program, so I could just call the motion function after changing the coordinates, and it will execute and go there. So let me see. So first off, whenever I do this, I'm going to do for loop. For sure I is less than 180. We're going to be we're going to create 180 points on an arc and iterating through those, and that's how it's going to get the actual walking motion. For now, again, this is going through 3 pre-programmed points. So for I is less than 180 degrees. Do I plus 1, or add 1 to I. Open the brackets. And yeah. Let me see. I did these calculations a few months ago, so I need to figure out where I was. Let me see here. I forgot we have to I think I need to do 2 sets of calculations because I is less than 90. Because if I need to change the math a little bit after it passes the halfway point, because the triangle I used to calculate the first 90 degrees disappears after the after it crosses the 90 degree mark. So I need to do this in order to deal with that. Let me see how I did this, if I remember correctly. So I know the angle, I know my stride length. Oh, that reminds me. I need to add an integer up here for stride length. And we'll set that to 0 for now. So I have to set the integer for stride length. This is what's going to determine our total step length. And whoop. And let me see. High in range. So we have our stride length, which is going to be, or we have our hypotenuse, which is going to be our stride length divided by 2, because our stride length is going to be from lifting the foot to placing the foot down. So we need the radius to calculate this. So we have our hypotenuse and our angle, our first angle being 1. So what we need to know is the height to position the foot at and how far away the foot is from the center of our half circle. And in order to figure that out, we can do, let me see here. Had 1.5 for this one. Where did I get these numbers from? 1.7, so I calculated my height first, my Z offset. And that came from, where did that come from? $945, 707, 1 equals, okay, 1 point. Where did this 10 come from? Alright, so that's one of the fun parts about this. I have to decipher my notes from a while back. Okay, I thought I saw the robot moving the stand. Where did I get these numbers from? 707. My stride length is 4 here. Oh, this is scuffed. So I don't remember where I got my numbers from. 17, 145, plus b divided by 2. Then I got 0.707. Then both sides. Oh, okay. Okay, I see where I got my numbers from. So we will do my, add another one. Actually, we'd write this straight to the z coordinate. Coordinate equals z coordinate equals sine I. I is going to be equal to our angle, and our angle is going to be whatever this current one is. So sine I sine I times our stride length Which, actually, let's set our stride length to 4. Put this in here, divide our stride length by 2 to get half. Stars, and then we will print. Whoops. Print our Z chord. Actually, let me change this just in case. That way I don't affect anything on the physical robot and I can test things out here. Oops. So, we can... Is that really all I need to do? And let's set our Z coordinate to... Can be set to 0. So, let's run it. Whoops. Huh? Stride length. Oh, whoops. Offset. See offset. Stride. Oh, forgot the underscore. Let's see what happens when we get out of it. Aha. Stop. Alright. Location 1, location 2. I should probably comment out these things. Comment out those. Run it. What else? I forgot to comment these out. No, not those. These. .14. That is not correct. All right. Let's see. I is less than. I is less than 90. Z offset. Coordinates. Oh. Do not print the Z coordinate, print Z offset. That explains it. Let us see here. Nothing. What is going on? print sine I. Sine I should give us print I. Maybe I messed up somewhere. It is not. Let me see. Does it even run the loop? I'm starting to think it's not running the loop. It is not running the loop. Integer I. Alright, what did I do differently? Oh. Oh. There we go. So let's print our Z offset. And let's see. So 0, 1.68, 1.82, some negatives. Hmm. What, 179, 172. So sine of 45 times 2, I should be getting 1.7 right there. But why is it negative? Zero, 1.6, 1.28. What is this? It's out of here. There we go. Let me see. 745, 707, 7. Hang on, I need a. Let me see. I need to look stuff up because I forgot what I did. Pretty sure that's what I did. Let me see here. We know 90, we know 1 degree, and our hypotenuse. Let me see here. So our angle is our hypotenuse times sine and our angle. That's what we got over here. We got sine I times our hypotenuse, which is our stride length divided by 2. That gives us our z offset, but why is it negative? That is the question. So let's just do this anyway. If I is greater than 90, our how did I do this? I'll turn this off for now just to save its battery. Let me see my camera. I wrote this code a while ago in Visual Studio to test it out and see if it even worked. How did I do this? For I in range 180, z offset equals 0, x offset equals 0. I less than 90, sine I convert it to radians. Ah, maybe that's what it was. I have to convert my angle into radians, I think. And I do that by increase to radians, pi times pi divided by 180. Sine I times does Arduino have a pi function? Does Arduino have pi? probably alright. What I'm finding, let me try this. Does that exist? If it exists, I'll see it print pi. Oh! It does exist. Interesting. The offset. Huh. Is this that it doesn't like? Let me try this. I times pi. If it doesn't work, then I know that something is seriously wrong. Okay. So it doesn't like this. I times pi divided by 180. Try that. Okay. Pi divided by 180. So that works. Z offset. See if that prints. Or if it prints 0 again. Oh. And that is our... what is that? That's our height. 2 being our maximum height. So, as that increases, we need to do something to get it to fall back down. Let's see if I can figure out what I did. Root. Stride length divided by 2 squared minus z squared. Oh, that's our x offset. My z offset is 180. Okay, so I just invert it. Okay. So z offset equals 180 minus I. And then z offset equals, and then I pretty much just do the same thing over here. And that should be it. Ah. That should be it. That should generate both our Z offsets in both directions. Whoops. Print line, the offset. Re-upload that. Man, I keep forgetting the semicolons. Let's see if we get what we want. Yes, it climbs up and it goes straight back down. And then after that, if actually I don't have to write another if else statement, I can just throw it all in here again. Alright, now the hard part is the X offset. So float X offset equals 0. So my X offset will be how do I do this? Should just be, so I have A, C, I have my angle. So now I need to calculate B. So A square, so I just did the Pythagorean theorem in here. So X offset equals square root or hypotenuse squared minus A squared. So our Z offset squared minus our wait, no, hypotenuse comes first. Stride length squared minus our Z offset squared. Put these in here so it performs these operations first. Throw a semicolon on the end before I forget. Line X offset. That's really all I did. So then once I get that, is that really all it is? Oh. What did I forget? Let me see. Nope. Here we go. Square What was this? Z offset. Where's that? Got the Python brain. Where that? Let's try now. I am missing a bracket. Yep. See if it prints anything. Let me comment out this, because this is clouding up everything. This does not look right. 4 and 7. That should be 0. That should be 0. Let me see. Times our X offset. Let me see here. Square root. Stride length divided by 2 squared minus Z offset squared. X offset equals X offset squared minus X offset squared. Why though? No, that should be correct. That other operation is for after I is less than. Okay, wait, no, yeah, I see, okay. So after this, our X offset is equal to X set minus square or X offset. Try and think about why I had to do that. I forgot why. Oh, it's to reverse it. Is it? Let me see here. So if I is less than math square root X offset minus X offset squared, then I should be able to just throw this in the other side, and it should work. What I don't understand is these numbers that are coming out of this right now. Why are we getting negative numbers? We're supposed to be getting negative numbers, but we're not supposed to be getting these negative numbers. Why did I square? Oh, I didn't square it. I see what I did. So I'm turning the x offset times 2. So I'm subtracting the positive number by itself times 2 in order to get the negative version of it. So I'm reversing it. Get that out of here. And that should give me the same values that I got for this side, except for negative. Let's see. So we start with 4 maximum. Start going backwards, 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 backwards. 4.6, and then it switches to positive. Range 180. What I don't understand is why X should get to 0 at some point. So let's give me my X offset. Hmm. .5, 2.10. Gives us our negative. 105. Something's not right. X offset. Let me print this. Comment that out for now. What is the square root of our stride length? It should be 4. Oh. That's where I messed up. Divided by 2. I forgot to half the stride length. That explains a lot. Should give us 4. The heck? Oh, whoops. Divided by 2. I should give us 4 now. Yes, that's what I want to see. Now give me my X offset. These are the numbers we want to see. There we go. Now it's going from backwards to forwards. So it's starting negative and going positive. That might be a problem. Let me see here. Comment these out. Make sure that these are working one last time. Okay, starts from 0, goes to 0. Maxes out at 2. Should max out at 2. Maxes out at 2. Okay, goes to 0. Alright. So that's working. I just need to switch these two sets of calculations. Throw this over here. And that should fix our problem. Let me see. Let me get rid of the Z offset. Print lines. That way we can only see the X print lines. Actually, no, I do want it the other way. Because this is going to be lifting the foot from our frontmost or backmost position to our frontmost position. So yes, this is what we want right here. Whoops. So this is what we want. Negative to positive. Make sure it works one last time. Negative to positive. Okay, good. Good. So now, once we get that, we also want, after the for loop is done, for I, whoops, int I equals 1, no, 0. Actually, wait a minute. No, I is going to be 180. I greater than 0. I think this works. I'm not sure. I need a... Does that work? Print. Fill that print line. I. Let me see if I minus even works. I think it does. Yeah, okay, it does. Except for let's make it... Because we do want it getting to 0 degrees. I is greater than -1. That should give us 0. Oh, hang on. There we go. Yep, gives us 0 now. Okay. If I is less than 90. Actually, no, we're starting from greater than 90. So all we need to do is the X offset math. Actually, yeah, we just run this again. We should be able to just run this again. less than 90. We can run this again, and then we only apply the X offset, no Z offset, to get it to move straight back. Zero. Yes. Then if I is less than 90, we run this code up here. For that, actually, let's keep that. Copy. Get rid of that. Wait, wrong one. It's this one. I is less than 90. Get rid of that. Run the code. And it should give us negative values. Yes. Okay, so this takes one step, and then it moves the foot straight back to reset. I can't just do that though, because if I give the stride if I give the total length of the leg to the if I feed the total length of the leg into this as the what was it? I don't remember. So these are offsets. These are offsets. All of these are offsets down here. Oh, you can't see that. So these that it's printing out down here are offsets. This is what I've been staring at. I forgot to show that. In fact, let me... Can I fix that? Window capture. You don't need to see up there. Come on, get the whole window. How many times do I have to do this? Okay, there we go. There we go. So these are what I've been staring at. These are the offsets for the walk cycle, and these are, like I said, offsets. So I have to subtract them from the current. The Z offset is going to be subtracted from the total length of the leg in order to get the height that the leg needs to be positioned at. And then the X offset is subtracted from our radius, which is our total stride length divided by 2. Actually. Yeah. Well, actually, no. The only one in here that's actually an offset is the Z. The X, the X, these are actual coordinates for the positioning of the leg in the X-axis. The Z axis numbers that I get out of here need to be subtracted from my leg length. So that can either be my total leg length or whatever I want the leg length to be at. So if I want it to have this bend over here in the foot while it's walking, it will be subtracted from that length right there. And the issue with that is if I divide my total leg length and I try and run this, it's going to try and put the foot too far out, further out that it can reach, and it will cause an error. In order to fix that, let me see here. I did some math to fix that. These little calculations. It defines your total leg length, total allowed leg length per step. And now I have to figure out how that works because I forgot how it works. How did I do this? For I and range length. X list. No, that's not. MC list. Fuck. Input stride length. Turn. How did I implement this? Slide kinematics. For I range 181. I is less than 90. Origin. Square root. Upper plus lower minus. Is that what I did? Sure, if upper plus lower. Let me see what I did here. So my stride length is 2. So 10 squared plus b squared equals 18. 18 squared. Where do I get 18 from? Oh. 18 is my total leg length. So we're trying to find B. Is that what we did in here? Upper plus lower. Two minus our stride length squared. So what am I solving for here? Upper. Oh. I see now. I see now. So we will put our float, corrected leg length. A corrected leg length here. Let's do that for neatness. So our corrected leg length print stuff here. Actually, no, I don't want to print stuff there. I want to deal with this first. So, material, print line, and then our corrected leg length. Then our corrected leg length. Oh. Our corrected leg length is going to be equal to, we will need to get the hypotenuse for our leg. So square root. It's going to be our 8. It's 8 squared. No. Total leg length squared minus our stride length squared. So our total leg length squared, which could be 18. Squared 18 minus our total, our stride length, right? Squared. Our stride length. Let's see what that gives. Oh, uh-oh. My fault. Actually, while I'm here, let's comment these out. Corrected leg length. Ah. See if that gives us what I think we're going to get. We should get total leg length before and after. So 17.5. We need those two. 18. We should be getting 14.9. Something's not right here. Let's stride length. Where did this 10 come from? My notes are very confusing. So it should be... Where did I... Oh, hey, there's someone else watching. Hey, if you're wondering what I'm doing, I am trying to get this thing walking. This is my robot. I think it'll... Yeah, so far this is what I got. It is cycling between 3 preset spaces that I gave it. And I am trying to figure out the walking code right now. Right now I'm trying to figure out how I compensated for the beginning and the end of the arc of the step. Because if I upload what I have in here right now and put the I start writing to the servos in the beginning and the end of the arc, it will exceed the amount of travel that the leg actually has, and it will error out. So I don't like that happening. That's not supposed to happen. So we have to compensate by calculating what the maximum leg length is for, or the maximum allowed leg length can be. And then that will be subtracted from, or the z-axis for that, the hypotenuse that I get for that is going to be subtracted from the z-offset that I calculated here and everywhere else that says z-offset. And this code down here is for the step backwards. So only the x offset is actually going to be written to the leg. So this thing takes coordinates right now. I have it set up so this thing takes coordinates from down here. So I can feed this the x coordinates that I get out of this code and ignore the z offset, and it will travel backwards. And just like that, he's gone. I didn't expect him to stick around. Now let's see what I was doing. Power that off. Let's see. Where was I? I was somewhere around here. Okay, corrected leg length. So our total leg length squared by our stride length divided by 2. Half of our stride length squared should give us no. 100 minus 2. What am I getting here? Something's not right. When did I generate this one? This slaps. 324. So this should get me Stride length. That's not supposed to be there. Bracket there. Take this. Put it over here. So that should give me 4. Yeah, it's giving me a bunch of 4s. So why is my stride length wrong? $14. That is not corrected stride length. Let's float. Square 18. $24 minus. Let's get rid of the square root. The heck? Square root 18. Need another parentheses over here. Wait a minute, is that my problem? I swear. Corrected leg length. Stride length. I swear, if that's if that was my problem, I'm gonna be slightly annoyed. 17.89. Actually, wait a minute. That is correct. Okay. So this calculation should run every time I do that. So instead of 18, let's change it to integer. Height. Let's change it to height. Equals 0 for now. We'll do 18 as a placeholder. So instead of this, we do height. Okay. So then we will take our corrected leg length and subtract it from our Z offset. And subtract our Z offset from it. Yes. Okay. So this is what will be written to the robot. And then like that, and then we can print our X offsets too. And this should be what our walking cycle looks like. Uh-oh. Probably shouldn't have printed all that at once. But so far, this looks good. And then at the midpoint, get here. This looks good. Okay, so after this, I'm going to comment these out. Comment those out. Let's see. And then our desired stride length, let's turn that to... What do I want it to be? Let me get my comically large calipers. So we want the stride length to be... I'd say 120 mils. Corrected leg length 0. Our desired height. Let's just do our total. So 355. Actually, wait a minute. Yeah, okay, 355. 355 millimeters. And I should be able to run that, and it should spit out what I want to see. Uh-oh. Not a number. Corrected leg length. Stride length. Set. Incrementers 1. Let's separate this. Block variables. So our X offset by 2. Double that. Let's focus on one thing at a time. The heck is this? Get out of here. Try printing this X offset up here. print both sides. Ooh, I dropped my notebook. Let's take a closer look at this. So, 60. Our desired stride length is 120. Half of it's 60. Gradually it's closer to 0. Passes the halfway point, goes up. So our X offsets are correct. Let's check out our corrected leg length. Not a number. Nice. Let's see why. Height. I set my height at 355. Square. Minus our Z offset. What does this give me? Hmm. The heck? Expected. What's a token? Oh. This should. Not a number. The mistake is somewhere here. What's our height squared? Y. $355. Wait a minute, I have an idea. What's the maximum value for an integer? Aha, it's maxing out. Okay. It's 355 squared is a massive number. Let me see what else I can use. A double? How big is that? Double size. Let's try that. Double. Where is it? Corrected leg length. So wait a minute. Ah. Double. Actually, wait a minute. No, I'm not. I'm not maxing out that. And what is my problem? Happens every time I do this. Hmm. Is it because... Is it overflow? Let me see. Try that. There we go. So yeah, it was exceeding. Huh. Squared 1260 25 1260 25. Okay. That means let's do that. Predicted leg length. Actually, let's change this back to a float. That value is never going to be very large. See what we print. $349. Okay. Then let's print our travel back. Okay. Corrected leg length minus C. Offset. Let's take a second to look at some of this. So 349. And it starts climbing back up. Okay, that looks right. So then let's do our D coordinate equals corrected leg length minus the Z offset, and our X coordinate equals our X offset. Then we run motion after each time. Then over here, we do we leave our Z offset alone. X coordinate equals X offset. I am scared to run this. Let me go my thigh angle. And my knee angle. Get rid of these. Print thigh and knee angle. And let's turn our travel speed down to 1 second travel time. And then we'll comment these out for now. Offset motion. Oh. What do you mean? Motion was not declared in the scope. Oh, it's capital M. Motion. And then not declared in the scope. Oh, I see. Let's see here. And then it should write them again. Okay. Our knee is rising. And our thigh is moving backwards. One, 5, 9, 6. Our knee should be falling at some point soon. Maybe I should have had a faster travel time. You know what? I'm impatient. Let's run it. Let's see what happens. That's not right. Oh. Why did it write? 99, 180. Let me lower the travel time, because this is taking forever. Alright, I'll figure out why the leg swings backwards in a little bit. That's annoying. Let's change that to 100 again, because this is taking... This is slower than I thought it was going to be. Is it gonna start stepping down? See the angles. Man, that takes forever. Where is this? Why does it keep going backwards? Let's see. Let's see, print our angle. Something's getting fed in here that's not right. X coordinate. Somewhere up here. Coordinate Z coordinate set to 0. Oh. Why did it do that? What's going on? Oh. What is it doing? What are you doing? Oh, this is taking forever. Let's get rid of our delay. Forget that. Oh, this is gonna suck. Oh. Uh-oh. What is that? Why does it keep kicking? Okay, I need to figure this out. Let's see if oh, put a delay. uh, let's do 500 milliseconds. Oh, come on. Let's see. Probably turn this on its side a little bit. Way it's easier to see what's going on. That's the angle. Stop there. These all look normal. So why is it kicking? Oh, you know what? Let me see. It looks like it's when it transitions between forwards and backwards. 0.9 line, end, step, delay, 1 second. And after this, it's going to be serial, print, line, and reset. And reset. Throw this in quotes. Those there. And let's try it. Hopefully it doesn't kick me. Oh. Ah, I hate that so much. Turn the timestamps off. It's gonna take a while. Much more of Suno's music. Oh, this is the last one for this page. Come on, kick. There we go. Could it be? Oh, I think I know what it is. Okay, I think I know what it is. It's the midpoint. It's the midpoint. It can't deal with 0. I think. You know what? I'm actually gonna take a break from here. I'm tired. I made some good progress. It kinda works. Not as well as I'd like it to, but meh. I'll take it for now. 2 hours. What the heck? Alright. I'm done for today. Goodbye. I'll work on it next time. Hopefully I'll get it working properly. And see anyone next time. Bye.